Welcome to the Switching Fundamentals video on MAC addresses. The intent of this video is to build on the concept of MAC addresses introduced in Switching Basics Part 1 and to give you a little deeper understanding of how they work and introduce you to how to read them. So as you recall, MAC addresses uniquely identify computers on LANs, and they're comprised of a 48-bit address, that is 48 ones and zeros, that are represented as 12 hexadecimal digits. And for those of you who are unfamiliar with hexadecimal, it's another way of representing numbers. It's easiest compared to the way we normally represent numbers, which is technically referred to as decimal. And so in our system of decimal numbers, we write numbers 0 through 9. And in hexadecimal, digits are written as 0 through F. And so what happens is you'll start off with your normal, 1, 2, 3, on and on. And then when you get up to 8 and 9, instead of just going over to the next column and adding a 1 to create 10, we'll then go on to A, then B, C, D, E, and F. And these represent essentially, so we know what 8 and 9, and so A will represent 10, B 11, C 12, D 13, E 14, and F 15. And so really, this is just a different way of representing numbers to try to make them easier to read, or at least shorter. And so again, MAC addresses will be written as the 16 digits that are usually split up into pairs, and so they're written one of three ways commonly. The first is using dashes, so separate each pair to make it slightly easier to read. Or similarly, depending on the operating system you're using, you may also see it represented as colons. And I realize they're not showing up very well from my pad here. And the last way, which is a little easier to write, is to break them up into fours, separated by periods. Now there are two kinds of MAC addresses that we'll see in networking. The first is what we refer to as universally administered addresses. And these are the most common. These are what's used in computer electronics or your home computer or anything that uses your wired Ethernet, the 802.11 wireless that you might use at hotspots, and also Bluetooth shares this universally administered address space. And this contains two parts, and so I'll draw a MAC address up here again. Now the first part is the first half, or the first 6 digits, is what we call the Organizationally Unique Identifier, or OUI. And this is what gets assigned to manufacturers to uniquely identify their brand. The second part of the addressing space is then referred to as the NIC-specific space, or sometimes the user space. And this is what gets assigned by the manufacturers to the individual network devices that they manufacture. But again, they must be universally unique, which means that there's no other address that matches this in the world. So, and also an interesting aside is, if you look up a MAC address, you can actually go on the internet and Google different OUIs, like look up your home network card MAC address or something, and actually find which manufacturer made the card, which can be handy in certain troubleshooting scenarios. And also, just for trivia, there happen to be 281,474,976,386 710,656 addresses available as MAC addresses. And according to the great brain powers that be, they don't think we're going to run out anytime sooner than the year 2100. So we're pretty safe for now. Now, the other kind of addresses that are available are what are called locally administered addresses. And these are often used on network gear or for other special functions. And in this case, the local administrator will actually define the address, or in some cases it's auto-generated when you turn on certain network features. And so you need to be careful with these because obviously since they're not universally unique, the possibility for overlap does occur, but as we'll see in later videos, there are certain protocols that actually take advantage of this to use MAC addresses in multiple places. And also, a related term is that these days, most devices can actually change their MAC address. And so when a device does this, we often refer to this as MAC spoofing, because it gives somebody the possibility or the potential to impersonate someone else, which can have security ramifications. And so the last point I'd like to make here is that just a reminder, for broadcast addresses, they're going to be written as all Fs. And so this, of course, in binary would be represented as all ones. To summarize what we've gone over, first, MAC addresses are composed of 12 hexadecimal digits, or 48 bits. Secondly, there are two kinds of addresses. The first being universally administered, which are, again, universally unique throughout the world. And we also have locally administered addresses, which are defined by the local administrator and are used for various network protocols and other functions. Thank you for watching.